What's up, team? Today we are talking about the slopes of parallel and perpendicular lines. So we know parallel lines, they never touch. We know perpendicular lines, they intersect at 90-degree angles. Now we're going to look at the relationship between two different parallel lines and their slope, and then two perpendicular lines and their slopes. Let's start with parallel lines. If you have two parallel lines, their slope are going to be identical. They're going to be exactly the same. So if line A right here has a slope of 6 and line B over here is parallel, you're told that it's parallel and you are asked what the slope is. Well, the slope is also 6 if they are parallel to one another. In the same way, if you have some line A that has a slope of, I don't know, 2 over 3, 2/3, and then some other line that's parallel, you're told it's parallel, that means this one also has a slope of 2/3. Parallel lines always have the same exact slope. Okay, perpendicular lines. Perpendicular lines, the slopes are opposite reciprocals of one another. So you have line A, line B. If line A has a slope of, say, 1/2, then line B would have a slope of -2. Let's remember, let's kind of review real quick what opposite reciprocal means. So say you have some fraction. We're just going to do this generally. Say you have some fraction A over B, and you wanted to find the opposite reciprocal of that. So to do that, you're going to flip the fraction. So to find the opposite reciprocal, you're going to end up with B over A. And because it's the opposite reciprocal, opposite here indicates that we're negating it. So you're going to either add, you're going to change the sign one way or the other. If it's positive, it goes negative. If it's negative, it goes positive. And you need to flip the fraction around. So another example that's a little more specific, say we actually utilize that 2/3 example, and we want to find the opposite reciprocal here. To do that, you'd flip it, so 3 is on top, 2 is on bottom, and it was positive, so it is now negative. If it was, say it started negative, say you have -2/3 what you started with, then the opposite reciprocal would be +3/2. Okay, let's do an example. So we have this line AB, and it's parallel to line CD. We're given that AB has a slope of -6 over 11, or -6/11. And the question is, what is the slope of CD? Well, we know that they're parallel. That's given to us, and we just learned a moment ago, if you have two lines that are parallel, their slope is exactly the same. So the slope, remember y equals mx plus b, a lot of times n is our slope. So the slope of CD is also -6 over 11. It's the exact same thing as line AB. Here we go, example number 2. We have different lines, I'll just give them the same name. So we have line AB, line CD, and they are now perpendicular to one another, meaning they meet at a right angle. AB has a slope of -14 over 19. Find the slope of CD. Well, we know that they're going to be opposite reciprocals of one another. So if AB has a slope of -14 over 19, the opposite reciprocal of that, we're going to have a 19 on top, we're going to have a 14 on bottom. We just flip spots. And this thing was negative, so it is now going to be positive. The slope of line CD is 19 over 14. Next example, we're coming at it from a different angle here now. Angle, it's terrible language to use in geometry class, sorry. Line EF has a slope of 6, we're given that. Line GH has a slope of -1 over 6. Are EF and GH perpendicular to one another? That's the question. So we're looking for a yes or no, and of course you need to justify the why. So if you answer a question like this, just yes or just no, no, that's not correct. I need to know why. So let's figure it out. EF has a slope of 6, and if GH is going to be perpendicular to this, it's going to be the opposite reciprocal. So let's just start with 6, and we'll find the opposite reciprocal, and if it matches this, then they're perpendicular. If it doesn't match, if it's anything else, then they are not perpendicular to one another. So let's find out what happens here. So the opposite reciprocal of 6. Well, we know that 6 is the same thing as 6 over 1. They have the same value, so let's put that in for funsies there. Now, if we were to flip this, we end up with 1 over 6. And originally it was positive, it now turns negative. -1/6 is the same thing as 6. So my response to this would be yes, a resounding yes. They are perpendicular to one another because their slopes are opposite reciprocals. And I'm feeling good, so we're gonna end that with a Z. Okay, friendly reminder, this should be review from Algebra 1, but you are going to have to look at different points either on the graph or just points, ordered pairs that are given to you, and find the slope in between them to determine if they're parallel or perpendicular. So friendly reminder, this is not new, but if you don't remember it, make sure it's in your notes. I want you to have it. So the slope formula here, it's y2 minus y1 over x2 minus x1, and there are different ways that the slope formula is represented. Sometimes you'll see it as delta y over delta x. This just means the change in the change in y over the change of x. It's the same exact formula. It means the same thing. Remember, the triangle is a Greek letter. It's pronounced delta, and it just means change. So you'll see that throughout math. The triangle in this sense is you pronounce it delta, and it means change. Another way that we talk about this more colloquially, maybe it's a little easier to remember, we'll say rise over run. I'm hopeful that you're familiar with that. Remember, rise means we're talking about the vertical difference, so it's how far up and down is changing. And then the run is the horizontal difference. So here it's how far it's moving left and right, which is, of course, the rise is the y values and the run is the x values. Okay, here we go. You got this.